721, which is titled Studying Quadrilaterals on a Coordinate Grid. We are going to answer the question, what makes a quadrilateral special? So question 784 says, consider the two line segments, AB and CD. So they give us 4 points. They give us the point A, which is at 0, 8, B, which is at 9, 2, C, which is at 1, 3, and D, which is at 9, 15. So on your coordinate plane, you're going to graph those 4 points, and you're going to label them A, B, C, and D. It should look something roughly like this. For point A, which is at 0, 8, you're going to go 0 to the left or right, and then you're going to go up 8, put a point, and label it with the letter A. B is at 0, 2, so you don't go any, sorry, that says 9, 2. So you're going to go to the right 9, up 2, put a point, and label it B. C is at 1, 3, so 1 to the right, up 3, put a point, label it C. D is at 9, 15, so you go 9 to the right, up 15, put a point, and label it D. Okay? These are each to be made into segments. So the first segment they want is AB. So you're going to connect A to B. If you have something flat like your student ID, you can draw it or the side of a folder. And then you're going to connect C to D, straight as you can, okay? On the right side of the paper, they want you to find the length of AB, and then they want you to find the length of CD. But unfortunately, AB is slanted and CD is slanted. So you can't just count it as how many units like you could if it was straight up and down or straight right to left. Okay, so if it's a horizontal line or a vertical line, you could just count. But since they're slanted, you can't. Okay? Instead, what you can do is use something called the Pythagorean Theorem by creating each of those into a right triangle. So from point A right here, you're going to notice that I dashed in a line all the way down until it was the same level as B. Then I dashed it over to B. Okay? That creates a right triangle. The Pythagorean Theorem says that these two legs squared added together is equal to the square root of that third side. We'll call that third side X, but you could call it C if you'd like. And here's how you find the length of AB. You're going to say that AB is your X squared. It's going to be equal to this side, which I counted was 6. 1, 2, 3, 4, 5, 6. And you're going to square it. And then the other side was 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? You're also going to square that. If you can't do that in your head, grab your calculator. But 6 squared is 36. 9 squared is 81. Add those two numbers together and you get 117. Does anybody know what the inverse operation of squaring is? Not dividing. That's the inverse operation of multiplying. What is it? Square root. So you're going to take the square root of both sides, and you get the square root of 117. 117 is not a perfect square. And so if you type it in your calculator and hit the square root button, it's going to give you this decimal. And we're going to round to the nearest tenth. That's why we use this wavy equal sign, because there's other numbers there that we're just not going to write them all. Okay? So that's saying that the answer is roughly 10.8. Okay? Now we're going to do the same thing for segment CD. But that's going to create a bigger right triangle, right? If you want to draw it on your paper, you can. But I just counted from C over to here would be 8, and from here up to D would be 12. So those are the two legs on that right triangle. 8 squared is 64. 12 squared is 144. Add them together, you get 208. The last step is to take the square root, punch it in your calculator, you're going to get something approximately 14.4. So when you write your answers on the lines, you're going to say that the length of AB is 10.8 units, and the length of CD is 14.4 units. All right. Question B, they want us to write an equation for line AB and an equation for CD, and we want to put them both in slope-intercept form. So for AB, we need to count the slope. Is that line going up or down? It's going down, right? You see how AB is going down from left to right? So is it going to have a positive or a negative slope? Negative. And so we want to look and see where it's crossing at a corner. It's not crossing a corner there or there, but it definitely is right there. So from here, you're going to go down 1, 2, over 1, 2, 3. So that one should be y equals negative 2/3, and then x, and it crosses that y-axis at positive 8. Line CD has a positive slope because it's going up from left to right. And so if you count, you're going to go 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. So it has a positive 3/2 slope. And if you extended this line down, it would be halfway between 1 and 2, which is 3/2. Or you could put 1.5 or 1.5. Lots of choices there. Okay. Part C says, what is the relationship between AB and CD? That is, are they perpendicular or parallel to one another? Are they parallel? Definitely not parallel. Are they perpendicular? So they look perpendicular. How do you know for sure? Anybody know how to tell for sure if they're perpendicular? John? They cross, which means they intersect, but that doesn't mean they're for sure perpendicular. There's one other way. It has something to do with their slopes. So this one has a slope of negative 2/3, and this one has a slope of positive 3/2. Josh? They are reciprocals of each other because they're flipped. So 2/3, if you flip it over, becomes 3/2. But there's one other thing that they have to be besides just reciprocals. Anybody know what it is? What's the sign in front of this one? Negative. What's the sign in front of this one? Can't see it, but it's positive, right? So one of them has to be negative, and one of them has to be positive. And they also have to be reciprocals. That's what we call negative reciprocals. So for part C, you're going to say they're perpendicular because the slopes are opposite or negative reciprocals. Part D says use algebra to find the coordinates of the point where A and B intersect. Can you look at the graph and figure out where it's at? Can you tell where they're intersecting right there? Where are they intersecting? The way the graph is drawn, those look like negative numbers, but it's just the line extending through them. They're actually all positive. So it looks like it's at 3, 6, right? Okay. But they want us to use algebra. All right, so they want us to take these two equations and either use elimination, substitution, well, clearly we've already used graphing, or equal values method to solve, okay? In this case, they're both already equal to y, so I'm going to use the equal values method, okay? So they're both equal to y. That means I can take those two expressions and set them equal to each other. So that's what I did right here. I said that negative 2/3 x plus 8 equals the 3/2 x plus 3/2. Then I didn't like all the fractions that I saw there, right? It's a lot of fractions. So I wanted to get rid of the fractions. So I did some fraction busting, right? What is the what denominator do they all, what number do all the denominators go into evenly? The 6. So if I multiply everything by 6, that's going to get rid of the fractions. It'll be a little bit easier to deal with, okay? So 3 goes into 6 twice. 2 times negative 2x is negative 4x. 6 times 8 is 48. 2 goes into 6 3 times. 3 times 3x is 9x. And then 2 goes into 6 3 times, and 3 times 3 is 9. Then I need to get my variable on one side or the other. So I'm going to subtract 9x from both sides just to move it over to the left. In the same step, I'm going to subtract 48 from both sides. But you could do that as 2 separate steps if you want to. Which leaves me with negative 13x equals negative 39. What is the inverse operation of multiplying by negative 13? Dividing by negative 13. And a negative goes into a negative, makes it positive, and then 13 goes into 39 3 times. Okay, so that's our x answer. Now we just need the y answer. So I'm going to take that 3 and plug it back into either of these 2 equations. This one looks slightly easier, but not much. So I'm going to say negative 2/3 times 3, bless you, plus 8. So the 3 and 3 cancel, so we have negative 2 plus 8, which is positive 6. 3, 6 is our answer, which remember when we graphed it back up on question 84, we got 3, 6, right? Clever, right? All right, I'm going to move this up and then turn over to page 19. There it is. All right. Top of page 19 says properties of quadrilaterals. So each shape below has some properties that make it special. For example, a rhombus has 4 sides that are congruent and opposite sides that are parallel. With your team, you're going to brainstorm a list of special properties for each of the shapes, and it says you're going to record them on a resource page, but you're just going to record them on here because there's enough room. And then you may want to refer to your work from 778. Okay. All right. All right, so after you're done writing all these in, if you need more time, I'll put them back up after we do page 20. Okay, so turn over to page 20 at the top, and question 86 says, am I special? Shayla just drew the quadrilateral and she named it after herself. How clever, S-H-A-Y. When you draw your own quadrilateral, you can do the same thing. The coordinates of its vertices are at 0, 0, 0, 5, 4, 8, and 7, 4. First thing they want you to do is find the perimeter. So if you have a straight side, like from S to H, and it's vertical, you can count how many units it is. But all of the slanted sides, you would need to use the Pythagorean Theorem like we did on the first page. So you would need to create a right triangle from this one, a right triangle from this one, and a right triangle from this one, and calculate it to the nearest decimal. They didn't leave us enough space to do that. So for right now, we're just going to write the answer. The answer is 15 plus rad 65, which is roughly, and this means I rounded from my calculator, 23.062 units. Bless you. All right, so Shayla thinks her quadrilateral is a trapezoid, meaning that it has the special properties of having at least one pair of parallel sides. Is she correct? She is not correct. And how can you tell? Because they are not parallel. From H to A, you go up 3 over 4. Up 3 over 4. And from S to Y, from here to here, you go up 4 over 7. So they are definitely not parallel, so you're going to say that she is not correct. Okay? Does Shayla's quadrilateral have properties of another quadrilateral that you have studied? Does anybody think they recognize it as any of the other quadrilaterals that are on the previous page? Yeah, that's as specific as it gets, is quadrilateral. So you're going to say not anything special, just a regular quadrilateral. Okay, meaning it has 4 sides, and that's about it. Even if Shayla's quadrilateral does not have a special name, it may still have some special properties, like the ones you listed in problem 785. Use algebra and geometry tools to investigate Shayla's quadrilateral and see if it has any special properties. If you find any special properties, be ready to justify your claim that this property is present. So I found 2 things. I found that HA was 3 over 4, which we already said that up here. Go up 3 over 4, but the one next to it, AY, is down 4 over 3, which makes it negative 4/3. These are like what we did earlier. It's the negative or